Okay, real and relative motion. So real motion refers to what a bone is doing in three-dimensional space. So this is independent of the joint motion, independent of other bones, ligaments, muscles that are attached to that bone. We're looking at a particular movement or motion, and we're saying what is that particular bone doing in space. And in the peripheries, we name this by the distal aspect of the bone. So relative motion refers to what the joint experiences. So in the periphery, this motion is named by the distal moving on the proximal real bone motion, and that gives us the relative joint motion. In the spine, it's slightly different, so we name the motion by the superior moving on the inferior segment. So this is what the joint feels, this is what the proprioceptors pick up on, and this is what the muscles react to. So this motion will be described by the direction, the speed, and the distance that the bones are moving through. So if we look at this example of rotating to the right, my hands are the driver. So my hands will be moving faster than any other part of the body. If we look at the pelvis and the lower limbs, the pelvis is rotating to the right. The femur is also rotating to the right. Real bone motion of external rotation. So you have both bones going right, but because the hands are the driver, the pelvis is going to the right faster than the femur. So that gives us a relative joint motion of internal rotation at the right hip. So the pelvis is rotating to the right, the femur is externally rotating or rotating to the right, but because the pelvis is going faster, the joint experiences relative internal rotation. And that will be the same if we look at the right knee. Again, the femur and the tibia are both rotating to the right, or both externally rotating, but because the driver is the hands, the femur is rotating faster, so that gives us a relative joint motion of internal rotation at the right knee. And if we look at that in terms of a squat, now if we look at this in terms of the real bone motion of the tibia, because the foot is fixed, it appears as if the tibia is moving forwards. The real bone motion of the tibia is actually extension, because the distal part of the bone is relatively moving backwards, as shown by the arrows. So the real bone motion of the tibia is extension. Now the motion we get at the foot and ankle is obviously dorsiflexion, and the movement we get at the knee is flexion because that angle closes, but the real bone motion at the tibia is extension.